Hey there, volume. Love volume, right? Because the formulas are easier. Volumes of pyramids and cones do have one extra step because they're a slightly more complicated figure, but not terrible in any way, shape, or form. So up here we have our formula that we learned for volume of prisms and cylinders, right? Area of the base times the height. The only thing that is different with the volume of a pyramid or a cone is that it only holds 1/3 of the volume. Why? Well, because it gets skinnier as it gets to the top, right? It doesn't stay the same size all the way up. So because it gets skinnier as it goes toward that single vertex, it will only hold 1/3 of the material. So in order to find the volume of a pyramid or a cone, we're going to use 1/3 area of the base times the height. I'm going to show you how to do that two ways because you can also think of it as base times height divided by 3. So I'm going to do one each way and you can pick which one you like better. When we're doing that, the base is always going to be the single face that is opposite that solo pointy vertex up at the top here. So you've got this one vertex, and then on the opposite side, you have the single base that doesn't have a match to it. And then you have a height that runs from that single vertex to the base. And it has to be at a right angle. You'll notice there's a small right angle symbol here. And you'll notice that all of the other faces of the pyramid are triangles. So first, we're going to write volume equals 1/3 area of the base times the height. Now, this base happens to be a square. So 1/3, the square is either 24 times 24 or 24 squared, and the height is 9. The height being that line that goes up and down from the vertex to the base, or you can think of it as Indiana Jones dropping a rope down the center and then shimmying down the rope to the floor of the pyramid. So first, I've got to do my exponent. So 24 squared is 576 times 9. I also know that I can very efficiently take 1/3 of 9. So since this is all multiplication, I'm going to do that step next and say 1/3 of 9 is 3 times 576. And then last, I would get my answer of 1,728 inches cubed. It's volume. So we're talking about, filling the pyramid up with sand because Indiana Jones broke in at the top. And so sand starts pouring into this buried pyramid. How much volume would the pyramid hold? We also have over here a cone. Now on this one, I'm going to do volume equals area of the base times the height divided by 3, just so you can see that it works regardless of which one you pick, and maybe you have a favorite. You will notice that in the diagram, the radius is 3, and you will notice in the diagram that the height is 5 meters. So I would do the same thing. I would say my height is 5 meters. I might even add in the equals h, and then my base is this circle that is opposite that single vertex. All right, so a circle is pi r squared. So this is going to be pi r squared times h, and then divide by 3. So 3.14 times the radius 3 squared times the height 5. And I'm going to switch this to approximately since I used 3.14 and divide by 3. So I'm going to have approximately 3.14 times 9 times 5. And I can do that string of multiplication along the top all in one step. I'm going to get 141.3, and then I will have to divide it by 3. And absolutely using a calculator in this section makes sense. The volume is going to be approximately 47.1 meters cubed. So nothing fancy, nothing splashy when it comes to this. The only difference is that you either have to take 1/3 or you have to remember to divide it by 3. So we go to the back, we are going to look at option C, okay? And it's a little funky, right? All they did was give you the base of the pyramid. The directions said, find the volume of each pyramid or cone below. So this is the base of a pyramid. So you have a trapezoidal base. So trapezoidal base of a trapezoidal pyramid. And then they gave you that the height is 7. So we're going to find the same thing, area of the base times the height, and then remember to do 1/3 or divide by 3. So volume equals 1/3 area of the base times the height. Now, depending on how you like to organize things, trapezoids are a little bit more of a cumbersome formula. You might go up here and say, I'm going to do my trapezoid work off to the side so that I can just plug it into this formula, no problem. So the area of the base is going to be 1/2. The 7 and the 12 are your base 1 and base 2. They are parallel. And then your lowercase h, the height of that base is 5. So it's going to be 1/2 times 19 times 5. And no one is going to begrudge you from doing 0.5 times 19 times 5. You can do it right across, and you're going to get 47.5 yards squared. That's the area of the trapezoid. So area of the trapezoidal base, area of the trapezoidal base. So now I can do 1/3 times area of the trapezoidal base times, and they gave us in the directions that the height of the trapezoidal prism was 7. And I would simply multiply the 47.5 times the 7 if it were me, and then divide by 3. So 1/3 times 332.5, and taking 1/3 or dividing by 3. And because you're dividing by 3, it's not always going to be convenient. You might find in this case it's 0.83 repeating, so you might go with the volume is approximately 110.8 yards cubed and round it off. And you'll notice because I rounded, I switched to approximately. All right, last but not least is a pyramid where they gave us the slant height, right? They gave us that lowercase cursive L instead of giving us the height. So we don't know the height that we need that goes down the middle. So off on the side, I'm going to draw my little right triangle, which has a slant height of 18. The entire base is 16, meaning halfway across the base would be 8. And the thing I don't know, capital H, is the overall height of the pyramid. So to find my overall height squared plus 8 squared equals 18 squared, I'm going to have to do both of those numbers squared and then subtract the 64 from both sides. Capital H squared equals 260. And then because I'm a little bit extra, I'm going to change my color just so I can see that I square rooted both sides. And the overall height is approximately 16.1 inches. Not a huge difference from the 16 along the bottom, but here's the thing. If you use that 18, you would be very far off from the actual height, which is 16.1. So again, you can choose when you're doing volume, you can do volume equals area of the base times the height divided by 3 if you like that one better. In this case, I'm going to do the area of the base, which is 16 squared, times the height, which is 16.1, and then I can just do divide by 3. Overall volume. Oh, I have to switch that to approximately because my 16.1 was not an exact number, right? Over here was a approximate. So anything that I do with that is going to be approximate. So 16 squared is 256. Still have to multiply by the 16.1 and divide by 3. Approximately 4,121.6. Still need to remember to divide by 3. Approximately 1,373. And I'm going to round it to 0.9. It's actually 0.86 repeating, but that's not terribly helpful. In the last example, you were given the slant height to find the volume of a pyramid or cone. Remember, you always need the height. So even if this were a cone, for example, if you had a cone like this, you could be given the slant height over here on the side of the cone, which might be 13, and you might be given, say, the diameter is 10, and you would have to draw that triangle, right, where you need the height, you use a right angle, halfway across is 5, the slant height is 13, and then you could solve for the height of the cone, which happens to be 12, because that is a 5, 12, 13 Pythagorean triple.